Hey guys, Mr. Milton here. Today we're looking at triangle inequalities notes. In this video, you should be able to list the angles and sides of a triangle in order, and you should be able to determine the possible side lengths of a triangle. If two sides of a triangle are not the same length, I should say different lengths, let's say that, then the larger angle lies opposite the longer side. And so in this example, we're going to list the angles from least to greatest. Okay, very important for us to pay attention to those directions here. All right, so going back, just expounding on this, when you look at a triangle, right, if we have a really narrow angle, the narrower the angle, the shorter its corresponding side is going to be. Okay, we have a really large angle or wide angle, the longer its corresponding side is going to be. So in a triangle, we know that all the angles have to add up to 180 degrees, but this just says when we have different lengths, the longer angle or the longer side lies opposite the larger angle. Okay, and so that's where this comes in. Okay, all right. So here it says list the angles in order from least to greatest. And so they didn't give us any angle measures, but we do have all the side measures. And so we can say, okay, what's the shortest side? Our shortest side is KL. Okay, its corresponding angle is M. Okay, our second shortest side is KM. Corresponding angle is L. Our longest side is 5.8 LM. Its corresponding angle K. Notice you can only list. You can't find the actual measurements of them. Not with this information. We can organize them. We can list them, but we can't say, okay, M has to be, 27 degrees. We don't know that at this point. All right. Next example, it says in triangle PHT, let me draw that really quick. Triangle PHT, PH is 16, TP is 20, and TH is 13. List the angles in order from largest to smallest. So here they're asking us largest to smallest. So our longest side is PT. That must mean our largest angle is H. Going down to the next one, our second longest is PH. So T. And then the last one has to be P, angle P. Okay, and this is from largest to smallest. Make sure you read those directions so you don't miss a question you know the answer to. Kind of the same thing. If two angles of a triangle are not congruent, then the largest side lies opposite the larger angle. And basically the same thing we just talked about. And now instead of focusing or being given the angle or the side information, we're given the angle information. So here it says list the sides in order from smallest to largest. And we have 45, 75. They only given us two angles, but like we said earlier, the angles of a triangle have to add up to 180 degrees. So these two together give us 120. That must mean that angle M is 60 degrees. Okay, and so now we can list these from least to greatest, smallest to largest. Our smallest side must be opposite our smallest angle. So our smallest angle is 45. Its corresponding side here is MN. So MN, our next smallest angle is 60. Its corresponding side is ON. And then the last one, MO. On to the second page, just looking at another one of those. It says, list the sides of triangle DVQ. I'm just going to draw that really quickly. Triangle DVQ. It tells us that angle D is 51. It tells us that angle V is 4x plus 3. Let me just draw that here, 4x plus 3. And they tell us that angle Q is 5x minus 18. What we have to do in order to list these sides, first we need to find out what these angle measurements are. And we can do that because we know that all three of these have to add up to 180. Okay, so 4x plus 3 plus 5x minus 18 plus 51 should equal 180 degrees. What's that give us? 33, 36, so 9x plus 36 equals 180. 9x equals 144. Subtracting 36 from both sides and divide by 9. We find that x is 16. Okay. Great, we solve for x. Not really what they're asking us here. They're asking us what the longest to shorter sides are. So we plug that in to see what it is. 16 times 5 is 80, minus 18 gives us 62. So I find out that this angle is 62 degrees here, 62. This angle is going to be 64 plus 3, 67. Okay, let's make sure all that adds up to 180 so I can be sure I'm right. 67 plus 62 plus 51. All right, great. So as up to 180, we can be pretty secure in our answer there. And so now, going from longest to shortest, our largest angle is angle B. Okay, so it must open to the widest side, and that's DQ. Next widest, our largest angle is 62, so DB. And then last, QB. All right, this is a little bit of a challenging question, so take a second to try to answer that. It says, which side is the shortest in the following diagram? And here they give us two triangles, okay? One on the left is an isosceles triangle. We can tell because of the markings of the sides. This is 30. So 180 minus 30 gives us 150 divided by 2 should give us 75 for these two angles here. All right. So this question is asking us for the shortest, well, before I go, this is 40, this is 90. That must mean that this is 50. All right, so now I have all the angle measurements for all the angles given to us there. So now, since we're looking for the shortest side in the diagram, we can start with PQR and say, okay, in this triangle PQR, what's the shortest side? Well, in that triangle, the smallest angle is 30, and so the shortest side in this triangle must be QR. Okay. Now, as we look at the triangle to the right, QRS, we know that QR was the smallest side of PQR, okay? But in this triangle, we have our angles of 90, 50, and 40. 50, the angle that corresponds with QR, is larger than 40, okay? So we should be pretty tuned into the fact that 40 is less than 50, and so RS must be shorter than QR. So our shortest side is RS. Okay, and that's more reasoning than having to write a whole lot of things down, but we're comparing our angles. Smallest side in QR, our smallest side in PQR is QR, but it's not the smallest side in QRS. All right, finally, we have our triangle inequality theorem. Kind of switching gears a little bit here. In a triangle, the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Okay, so it's written to say whatever two sides I choose, A plus B, A plus C, B plus C, it has to be greater than the third side. And if it's not greater than the third side, then it is not possible to make a triangle with those lengths. Okay, what ends up happening is you either have a triangle that looks like this, where you're not able to touch the sides, or a triangle that looks like, and I'm terrible at drawing these, but a triangle that looks like this, where there's no way to make it work for meeting at a triangle at the vertex. Okay, it says, can a triangle have the given side lengths? We're given these side lengths 4, 6, and 9. Okay, remember that our rule is that any two sides needs to be greater. The sum of any two sides needs to be greater than the third side. So here's what I do. I always take the smaller two sides, 4 plus 6, and I say, is that greater than the third side? 4 plus 6 is 10. 10 is greater than 9. Can these triangles have these side lengths? Yes. Okay, because now any other combination that we make, 9 plus 6 is greater than 4 has to be. 9 plus 4 is greater than 6 has to be, because 9 is greater than both of those. Okay, so typically, if you add the two smaller sides together and it's greater than the larger side, you should be good. All right, B. We got 12, 3, and 7. So my two smaller sides are 3 and 7. Is that greater than, is that greater than 12? Well, 3 plus 7 is 10. 10 greater than 12? It is not. That is not a true statement. So we cannot make up a triangle with those side lengths. Finally, we have 5, 5, and 10. Okay, so I take my two smaller sides, 5 plus 5. Is it greater than 10? Well, I look at it, 10, because that's 5 plus 5 is greater than 10. That also is not a true statement. Remember, our triangle inequality theorem says that we need our two sides to be greater than the third side and not greater than or equal to. So therefore, that is not a solution. Or that those three side lengths would not make up a triangle. All right, finally, it says the lengths of two sides of a triangle are given. Find all the possible lengths of the third side. Okay, so we've got two sides of a triangle given. And the way that I think of this problem is I think, okay, what is the smallest possible side length for this third side? And what is the largest possible side length for this third side? Okay, and so here's how I think of it. Between these two, what if 9 is the largest number? Okay, kind of going with the same thought process here. If 9 is the largest number, I need my small side plus the other side to be greater than 9. And so I would solve for what my small side is going to be. Subtract 7. Small side has to be greater than 2. Okay, this is my minimum. Okay, so in my inequality, I'd say, okay, I'll just say side, even though I used S for small side. S is greater than 2. Now remember that that's not the only thing, right? Could be the small side, but what if our unknown side is the largest side? If it's the largest side, then we know that 7 plus 9 has to be greater than our side. Okay, so just putting this in a way so I can, my small side has to be less than 16. Okay, now you can write it like this and say, you know, S is greater than 2 and S is less than 16. Or, and this is probably the preferable way, especially to recognize it, you could write it as a compound inequality, okay, with S in the middle, saying S is greater than 2 and less than 16. It's probably the preferred way to do it. And this is how we find all possible side lengths, is in an inequality form. We don't say 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? Because we're then excluding all the decimal and fractional answers. So when we write it as a compound inequality, we include all the possible side lengths, and that's what this means, okay? All right, this next one, try it out. I'll give you just a second to answer this question. All right, here we go. So let's treat it like the small side. If we're missing the small side, we'd say, okay, this side plus 14, our two smaller sides, needs to be greater than 13. Okay. If we set up our equation for the large side, we'd say, okay, our unknown side is the largest side, then 14 plus 23 needs to be greater than our side. And we solve for both. Okay, subtract 14, we find that S is greater than 9. Okay, these two together, not really a whole lot of algebra there. S is less than 37. So now we can write this as a compound inequality. It's greater than 9 and less than 37. Oops, not what I wanted. There we go. All right. And so there is our triangle inequalities theorem and the finish of our chapter. All right. See ya.